Okay, we're back in the side table at Mr Chippie's workshop. And I can get away with a bit because he's not here at the moment. And so here we are with part 2 of the 1205 GS power supply. Now there is a difference between there's another one which looks the same, but it's the G, and here's one which was lurking from earlier. So this Kobishi is the pp2 and it has a different board. We're going to explore the differences of that as well. Oh yes, it's got a... No, I don't know. It's supposed to have a different board anyway. I might be lying. Anyway, we'll look at that as well later on. Well, what we're going to do is I want to take this printed circuit board out, and I want to take every single component off the board, and then I want to photocopy the board, and then we're going to make a brand new board, because that's going to be my build a dodgy power supply project, you see. Now I'm having to work on the camcorder, and I keep looking at the little monitor screen that I've folded out and trying to place this so you can actually see it. It's not like I'm in the other room with monitors everywhere. So we're going to get rid of that fuse holder, which is of the type which is banned in this country. And what else are we going to do? We're going to get this board out, and that's going to be fun. So I'm going to pause the camera while I get the board out. I bet you're glad I bought this off eBay instead of you. Right, well that took some getting the nuts off. Board identification, P16. So the next thing I'm going to do is I'm going to jot down the colour of all the wires, and I'm going to unsolder every single one of them. And then we're going to have a bare board, and I'm going to take all the components out. And this is so I can replicate this for our project. If you're just repairing one of these, it's just a matter of changing the 4 capacitors. And just looking at them quickly, 2200 at 25 volts and 100 at, I think it's 16 volts, but we'll verify that later. This has been bought as a working power supply for decent money off eBay, but I'm going to get this case through the dishwasher and probably give it a quick spray as well. Radio Crunch, if you're watching, you did the front panel. If you scanned the front panel, it saved me a job if you've got the scan handy. Oh, it's very kind of you, thank you. So then we'll sort out the fact that we've gone over to radio on the tannoy system. So what we have here is the mains lead goes in. We've got the live side, which correctly goes to the fuse. But then, instead of it going to the on and off switch, it goes to the transformer. And the neutral goes to the on and off switch, which is the wrong way around. So it should be fuse, switch, and then the transformer. And ideally it would be a double pole switch, but it's only a single pole switch. I haven't got a huge problem with that, as long as we're switching the live and not the neutral. So that needs altering, we'll have to change the wiring there. We also need to put sleeving on the main side of it, so that there's no, a child can't poke something through the ventilation slats, because as this is, imagine that with the lid back on, pokes the board back in, you can actually do that and touch that live fuse holder. Right, I'll pause the camera, I'll get those parts unsoldered. Okay, that's the bare board out now. So I've been writing down the components. I've already worked out that the series power transistor on that heatsink, which is usually 2N3055, but I haven't verified with this yet, that the blue is emitter, the yellow is base, and the collector is red. So that's verified that. The red and the black wires coming off the board at this corner go to the LED, and then we have black, violet, violet. So it's 16.5, 0, 16.5 the transformer. So it's 33 across the violet. So 16.5, 0, 16.5 is how that works out. So I'll just go a bit further into it and we'll end up with a blank board. And we know the diodes here are going to be something like 1N540 something or other. 1, 2, 3, well, any of them will do, because it's only having to work at 30 odd volts. The power transistor there is 0.1 ohm. .1 R 5 watt. So that's that. The transistor TO2 20 case transistor is a 2SD325. So I'll put that down. 2SD325. We've got those in stock because I've planned this. We're just going to check these resistors. There's 3 resistors, and these are all kind of half watt rated. So we'll probably up them to 1 watt. So I'll pause the camera and we'll take a few more parts off. Okay, so we're left with a pile of parts now and a blank printed circuit board, which I'll now photocopy. We've also got a list, so we know which is the positive and negative end of the capacitors. The smaller capacitors turned out to be 100 microfarads at 16 volts. The 3 amp rectifier diodes are 1M5400, so anything in that series will do. The series resistor for the LED is 820 ohms. The resistor up there is 1K5. The power resistor, I think we mentioned, was 0.1 ohm at 5 watts. And the other resistor, wherever I've put it, is 1 ohm. I've not written it down. And blow me, there isn't a pen here. So that's 1 ohm. Right, so we've got a pile of parts, and I'm going to check these capacitors with you. Hopefully we'll put it in a position that the camera can... Has it got the stand on these now? I'll prop it up with the pliers. Now what we find is as capacitors fail, they start to go high in resistance, but they go leaky as well. So this should be 100 microfarads. So I wouldn't want it to be more than 110. 119, so that's failing. $127, that one's failing. First of the 2200s. $21.35, that's actually low. $21.23, so well, that's a bit low. So I say this was a working power supply, and that's why I bought a working power supply, so we can do these tests. It's all well and good buying a broken one. Once we've diagnosed and dissected this, we know how it should work when it's a worker. Oh, the little Zener diode is 15 volt, and I'll just actually I'll just check that with our Zener tester. So I'll put that test meter back. For those of you outside the UK, these British made peak test things are absolutely wonderful. They're not exactly free, but where are we? Here's the Zener one. think Radio Cruncher came to the conclusion these are 15 volts, and although it looks like it's 400 milliwatts, we'll be replacing with 1.3 watts. 14.98 do nicely. So he's right, they're 15 volts, which is wonderful. So the next thing I'll do is we'll get that on our scanner, as in flatbed scanner. No, whoops, trips over the light. Not the radio scanner, the flatbed scanner. And we'll scan that printed circuit board. And hopefully I'll get Mr Chippie to do a acetate paint thing on it. And then we can rattle them off with the printed circuit board equipment that we have here, which I think we've shown you before when we were making that 1.8 megs transceiver. Right, so I'm going to pause it at that and we'll see what happens when I come back. So to conclude part 2 of this video on the PS1205 GS Taiwanese banned power supplies, or banned from the UK for safety reasons. I'm going to take that transformer out and we'll get that through the dishwasher. We'll get the unsafe fuse holder off. We're replacing the... Oh, I don't think we are on this one. We're not, but no, because it's complete. Well, I've got them in stock because most of these have lost their binding posts. So we're going to be replacing all the ones that have managed to lose their binding posts over the years. So this one will be alright in that on that side of things. So that's that. I've done the scan of the printed circuit board here, and I'll get Mr Chippie to put that on some software program, and I want him to fill in the copper bits black, and I want him to fill in the printed circuit board bare bit white. We'll get that onto acetate and we will make a couple of printed circuit boards, because I want to replace the one in this with this one I'm making, and that will give us then a second one for the one we're building from scratch, and it'll keep us the original as a template for drilling. So that one's going to end up with a new board. And I've been busy ordering from RS. In fact, I got carried away ordering from RS because there's my box of power supply parts. So we've got the 100 microfarad ones here. I think I bought 500 of them. Oh yeah, I did, didn't I? And how many of the 2200s did I buy? Oh, I bought 250. And then I've got some of these fuse holders, which are the replacement ones, 627293, made in Japan. What about that? And it looks like I've bought about 50 of those, and I've even bought a couple of new transformers, because we're going to come up against some of these where the transformers want changing. And what have we got here? And these will be good for 3 amps. So we're replicating the 5 amp circuit, but it's going to be a 3 amp power supply the way we're doing it. So that's the plan. I think that's 4 amp actually, that transformer. In other words, I want it to be a bit more tonker than it was, even though I never had any electronic problem with it. That's what we're going to do. Oh, and the Zener diode was 15 volt, and there's some of those 2SD235 transistors which we've got in from another source, probably from China. So that's it so far. So in the next part we'll either be making printed circuits on the video, or I'll have made printed circuits on the previously, and that's where we're going to progress. So we're putting the parts on a board, hopefully in part 3. So thanks for watching part 2, and I hope you're all going to rebuild your banned Taiwanese power supplies from 1981. Thank you for watching.